Hi students, in this session we are going to discuss about application of operational amplifier. The last session we have discussed about the introduction about the operational amplifier. In our syllabus we are having so many applications were there. In our syllabus we are having 4 applications of operational amplifier. What are there? The first one is inverting amplifier, and second one is non-inverting amplifier. Third one is peak voltage detector. Fourth one is comparator. We will see one by one. The first one, inverting amplifier. We will derive the gain equation for the inverting operational, that is inverting amplifier using operational amplifier. This is a circuit diagram of inverting amplifier using operational amplifier. See here, this is the operational amplifier. Now we will derive this gain equation for this inverting operational amplifier. We know the gain equation AB equal to V out divided by V in. That is output voltage divided by input voltage. Here, consider this is the point in which the voltage V1, consider assume that here V2. If you want to know the input voltage, if you want to write we know the Ohm's law, V equal to IR. In the input side, if you are writing the equation, VI, that is V in minus V1 divided by V equal to IR. So, V equal to I values, the current flow here is I, input current. IR, no, here R in. We can simply write as I in R in. Okay, this is equation number 1. Next one is, if you are seeing the output side, here V out. Output side, V1 minus V out. V1 minus V out equal to, the current flow here is IF. So, IF or F. This is equation 2. Okay. In the equation 1, so see here, the current flow is I in. The same current is flowing here. So, we know that I in equal to IF. We know that I in equal to IF. Substitute this I in equal to IF in equation 1. After substituting value, Vi minus V1 equal to IF into Rin. This is equation 3. Okay. And another one assumption is there, in an ideal operational amplifier, we know that V1, that is voltage in the inverting terminal and voltage in the non-inverting terminal is equal. See here, the voltage in the here it is connected with the ground. That's why this value is 0. Hence, substitute V1 equal to 0 in equation 2 and 3. See here, in ideal operational amplifier, we know that V1 equal to V2. Here, V2 is connected with ground, that is V2 equal to 0. That's why V1 also 0. We substitute V1 equal to 0 in equation 2 and 3. After substituting the value, we get minus V out equal to IF RF. Consider this as a equation number 4. And in equation 3, if you are substituting V1 equal to 0, we are get V input equal to IF Rin. Consider this as a equation number 5. We know that the voltage gain AV equal to V out by V in. That's why we are putting 4 divided by 5. So, minus V out divided by VI equal to IF RF divided by IF RIN. So IF get cancelled. So we get V out by V in equal to minus RF by RIN. This is the derivation for gain of the inverting operational amplifier. So again repeating that why it is inverting amplifier. We are giving input in the inverting terminal. We know that if you are giving input like this, we should get the output, the amplified version of the inverted signal. The magnitude heads is inverted. So here we know the Ohm's law. According to Ohm's law, the input side we are seeing Vi minus V1 equal to I in R in. The same way, V1 minus V out equal to IF RF. So we know that the same I in current only flew through the RF. That is I in equal to IF. Hence we substitute I in equal to IF in equation 1. The equation 1 becomes Vi minus V1 equal to IF RN. And we know that V1 in the ideal operational amplifier, V1 equal to V2. Here V2 is connected with the ground, that is V2 equal to 0. Equal to means, so V2 equal to 0, hence V1 also equal to 0. We substitute V1 equal to 0 in equation 2 and 3. After substituting V1 equal to 0 in equation 2, we get minus V0 equal to IFRF. Here, Vi equal to IFRN. So we know the voltage gain equation, that's why V out by V, divide the equation, we get the gain value. Next, we move to the non-inverting amplifier. Here, we will use the Kirchhoff's current law. What is current law? Kirchhoff's current law. In a node, incoming current equal to outgoing current, or else in a node summation of current equal to 0. See here, we choose this node. In this node, the incoming current, that is incoming current is IF, outgoing current is I1. We know that I1 equal to IF. So again we are coming to the Ohm's law. V equal to IR. I equal to V by I. I equal to V by R. We are going to use this format. So we know I1 equal to V1 divided by R1. See here, the other end connected to the ground only. So I1 equal to V1 by R1. Here, IF equal to this point V out. So, V out minus V1 divided by RF. Why it is look like this? The current flow is from here to here. That's why we are writing V out minus V1 divided by RF. Okay. We will do the cross multiplication. That then we are doing cross multiplication. So we are getting RF divided by R1 equal to RF divided by R1 equal to V out minus V1 divided by V1. Okay. So if your RF divided by R1 equal to V out divided by V1 minus 1. See here, this is the point V1. Again, we has the assumption. Assumption as V1 equal to, V1 equal to suppose here V2 means, assume V1 equal to, this is the amplifier assumption. So here V2 equal to V in. Hence, V1 also V in. We can simply write as Vi. So, if you consider this is equation number 1, this is equation number 2, this is equation number 3, this is equation number 4. In equation 4, substitute V1 equal to Vi. So, Rf divided by R1 equal to V out divided by V in minus 1. So, V out divided by V in equal to 1 plus Rf divided by 1 plus Rf divided by R1. This is the gain equation. So, gain AV equal to 1 plus Rf divided by R1. This is the gain equation of the non-inverting amplifier. I hope you people understood. So here you are seeing Kirchhoff's current law. In a node, incoming current equal to outgoing current, or else the summation of current in a node is equal to 0. Here the outgoing current is I1, incoming current is IF, I1 equal to IF. So I1 using Ohm's law, I equal to V by R, I1 equal to V1 divided by R1, because this is connected with the ground only. Then here the current flow is from here to here, that is V out minus V1 divided by RF. Just doing cross multiplication. After doing cross multiplication, already in ideal operational amplifier, we are having an assumption that V1 equal to V2. Here V2 is connected with V in. That's why we are also substituting for V1 is also equal to Vi. Simply V in is written as Vi. So in this equation, we are substituting V instead of V1, Vi. So V out by V in equal to AV. So AV equal to 1 plus RF by R1. This is inverting amplifier. Next, peak voltage detector. The working of peak voltage detector is to find the maximum amplitude in the given input signal. See here, y-axis we are having V out value. This is the time value. If I am giving input value like this, this is the given input signal. This is our V out value. V out value. It find the V out peak voltage value. This is the output waveform of a peak voltage detector. It consists of diode, capacitor and MOSFET switch. When you are initially, the capacitor is charged with Vc. So, if the V in value is greater than Vc, then the diode D is forward biased. Then the diode D is forward biased. So in this time, the circuit is acting as a voltage follower. It means that whatever the input voltage we are giving in the output, that will be delivered in the output. So if V in value is greater than Vc, that time diode is forward bias. It is act as a voltage follower. For example, if Vc initial value is any 3 or 4 volt, the initial peak voltage is 10 volt means, so it compare the value that will be stored in the capacitor. That will be stored in the capacitor, that will be get the output. So that's why whatever the input voltage we are giving, that is given, we will get as output in the output side. Then if V in value is lesser than Vc, what happened? Diode equal to reverse bias. Our diode in reverse biased. In this condition, the Vc value is retained, the capacitor values. The capacitor value is retained in this circuit. Okay, there is no change in the output. Suppose if you want to reset the circuit, a MOSFET switch is closed to reset the circuit to make the Vc value as 0. This is about the peak voltage detector. So peak voltage detector. So this is the output, sample output of the peak voltage. This is a time. This is V out. This is a given input voltage. This is time, V out. These are the given input voltage. It has the peak volt value. then the output will be the maximum peak value of the given input voltage. It initially the capacitor is stored with the value Vc. The input voltage is compared with the Vc value after giving Vin. Vin greater than Vc, the diode get forward biased. It acts as a voltage follower. If it Vin value is lesser than Vc, it is in a reverse biased. In this condition, the capacitor retains the value Vc. If you want to reset the value, reset the circuit, the MOSFET switch is used here. What is the drawback of this peak voltage detector? In between this value, any minimum peak values found, it won't get that. This is the drawback of the peak voltage detector. Next one is a comparator. In a comparator, what is the working of comparator? It compares the voltage given in the two input terminal. So here the negative terminal is taken as a reference terminal and the positive terminal we are giving a input voltage. Here this is positive supply, this is negative supply. Here the output diagram is here the output diagram is looks like this. This is a input value, this is V out value, this is plus VCC, this is minus VCC. This is the output of a comparator. How it is working? So V in value is, see here, V in value is, if V given V in value is greater than V reference, then what will be the output? V out equal to plus VCC. So this is the region. V in greater than V reference. In this region. Okay, the same way. V in lesser than V reference. Then V out equal to minus VCC. So in this region. V in lesser than V reference. This is the working of comparator. It compares two outputs value and it says which is the highest value. Again, I am repeating the concept of comparator. We are giving input in the positive terminal. This is reference voltage. If the V in value is greater than reference voltage, the positive value is given as an output. If V in is lesser than V reference, that is negative VCC supply is getting as an output. From that, we know the output is V in values either high or low. This is the equations for the comparator. This is a pictorial representation of output waveform of the comparator. Thank you guys. In the next class, we will see the that is effect of positive and negative feedback amplifier and practical analysis of feedback amplifier. Thank you guys.